Worksheet 14C, single pressure vessel. A cylindrical pressure tank is made of 10 millimeter steel plates, which is the thickness T, as you can see there. The normal stress at point A on the plane BB, which is the stress, normal stress measured perpendicular to the surface, right? That's why they say which is perpendicular to the surface of the plate at A is 80 megapascal in tension. What is the pressure of the fluid in the tank? That is the question asked. What is the pressure of fluid? So with either what is P in here, the internal pressure of fluid. So first we need to verify whether the single pressure vessel theory valid. So first one that you can see is single pressure vessel valid, theory valid. Even the question don't ask, just to be safe, to check before we can apply the question. So to make it valid, we already know that is the Ri over T have to be greater than 10, right? So Ri in this case, as you can see, the inner diameter is 1 meter, so the Ri we have equal to 1 meter divided by 2, so it will be 0.5 meter, or Ri equal to 500 millimeter. So from that we can plug in here. We have Ri over T equal to 500 millimeter over T with the 10 millimeter and equal to 50. And 50 for sure is greater than 10, and that is okay for this theory. So from that, okay, then we apply for the cylindrical pressure vessel. So from that we can apply for cylindrical single pressure vessel. So we have the hoop stress and we also have the longitudinal stress. As you recall, the hoop stress equal to P Ri over T, Pi over T, and we plug in here, and you can see the R in this case is 500 millimeter. So Ri over T is 50, so you have that equal to 50 P's. And of course we also have sigma, and that is sigma 1, and you can see that for the hoop stress. And the longitudinal stress equal to P I over 2T, so for sure it will be half of the hoop stress, so which is equal to 25 P, and that is sigma 2, based on the lesson note that we have it in there. Now what we do with the information that they give us is the normal stress on the plane BB equal to 80 megapascal in tension. So let's draw the block at A from there. Let's draw a block so that we can see what is that about. State of block stress. Okay, so let's draw the state of stress. So state of stress, put here, we have there, everyone see that? And then we have longitudinal, so that is sigma hoop equal to sigma 1, and that one here is sigma longitudinal, that is sigma 2, also sigma 2 on the other side. And that given is the normal stress on plane BB and the angle is 35 degree from horizontal, 35 degree. So let's draw that down. That plane BB, put here 35 degree. Okay, so that angle that they give us here is 35 degree. 35 degree. And the sigma of that is perpendicular to the surface. So as you can see now that the sigma that concerned, that given in this case, is the sigma perpendicular to that, because that is the normal stress, right? So that angles here from that surface, that is the sigma they give us. In that case, sigma, let's call that is sigma on plan BB. So let's call that is BB, right? On that, so sigma B in this case it equal to 80 megapascal in tension. So that's why I put go out of the cut 80 megapascal. 80 megapascal. So from that, as you can see, with the angle here with geometry that 35 degrees, we can also determine that angle from the sigma 1 to this angles exactly 35 degrees, same as with the geometry. Okay, because that angle here, right angles, and of course the vertical sigma 1 vertical go to the horizontal line here, it also vertical. That two angle will be the same 35 degrees. So what does that mean? The sigma B, which is the plane BB, rotate 35 degrees counterclockwise from sigma 1, from the plane that have sigma 1. Okay, so with that we can draw the Morse circle to see how that look like. Draw the Morse circle to see how this look like here before we can apply the equation. And Morse circle, as you can see in the cylindrical that we have it in the lesson note, that here tau, and we have sigma, in this case it MPa. So we have 2 points. This is sigma 2, which is longitudinal, and this is sigma 1, which is the sigma hoop stress. Okay, so from that we can draw the angle. For your if you're not sure what is that about, I can plug there. Here, go to the lesson notes, so you can go back to review what we are mentioned here in the what I'm talking about, state of stress for the cylindrical pressure vessel here. So again, we can go back there. I'm going to draw the same for yes. So that angles here we have sigma 1 equal to the hoop stress, and then we have sigma 2 here equal to longitudinal stress, just 2 points. Then with that 2 points, we can be able to draw the Morse circle with that 2 point on the circle, right? So let's make the circle a little bit better, hopefully, with the second try. Yeah, okay, look better. So the center at the Morse circle is the sigma average. So the center here is the sigma average, as everyone know. So that one here is sigma average, and the location is sigma average 0, right? Sigma average 0, and the plan B is 35 degree counterclockwise from the sigma 1. Okay, so from that, what does that mean? It means that all from the horizontal plane that have sigma 1, the hoop stress, as you can see in that state of stress. So it's on the Morse circle have to be double. From 35 degrees, it become 70 degrees. Everyone okay? So from that plane, sigma 1, and you can see that is the point we are talking about here. Point there, that point, counterclockwise 70 degrees. So we have the And this point basically represent the stresses for plan B. So that what does that mean? This point have the 80 megapascal for the normal stress, and of course whatever in the question mark on the other side, and we are not interested in here what question mark here, that is the vertical, the tau, but the question don't ask that, otherwise we can be able to find out later on. And the angle here is, as you can see, counterclockwise, and that here is 2 theta equal to 2 times 35 degree, and that equal to 17 degrees there. So from that, what can we have for the equation here? So as you can see now, with that we can project it down here. So this point, actually that is the 80 megapascal from the original to this point. So it's 80 megapascal. So let me write down here. That is the 80 megapascal. Now, what we have to make the relationship with the trigonometry. Okay, so make with the trigonometry. So as you can see, to find out the radius, to find out the sigma average, then we can do the complete the problem. So as you can see, we have sigma 1 equal to the hoop stress, as you can see, equal to 50p, and we have sigma 2 equal to 25p. So average, sigma average, is equal to sigma 1 plus sigma 2 over 2. So it will be 50 plus 25 divided by 2. So it will be 37.5 p. And then we also need to find out the radius. There are multiple ways to find out the radius of the circle. In this case, as you can see, sigma 1 minus sigma 2 is the diameter. Okay? Then you can have that the sigma 1 minus sigma 2 over 2. Okay? So from that, we can plug in sigma 1 is 50. Sigma 2 is 25, so it's 25 divided by 2, that we have it 12.5 p. That is the radius, because the diameter is sigma 1 minus sigma 2, as you can see. So from that, what do we have here? We apply the triangles we have, then you can see these components. What does that mean? It equal to 80 megapascal minus sigma average. And this is the radius. So the cosine of that angle, 70 degrees, equal to adjacent over the radius, right? So let me call that is the name for the point here. So that the center A, B, C. Okay, A, B, C. Let's put the B up here so it associates with the plane C. So from that, as you can see, we have cosine of 70 degrees equal to adjacent hypotenuse AB. AC, basically that is 80 megapascal minus sigma average, hypotenuse 12.5 p, and sigma average equal to, so let's put the radius first before we put down there the number. So what does that mean? The cosine 75 degrees, 70 degrees. Let's see, that equal to 0.342. 342 equal to 80. Sigma average 37.5 P over 12.5 P. So from that we can have the P equal to 0.80 divided by, simplify that equation, you will get 342 times 12.5. So from that we can get 1.9.15. So it will be 1.915, and the answer is megapascal. And that complete our problem. You see that there. So that is worksheet 14C.